This video will have a look at developing linear equations from a word question that involve only one variable. So by the end of the video, you'll be able to use a word description and develop it into a linear equation. So the steps in developing a linear equation from a word question. Step 1 is going to be define the variables in the question. After you've defined the variables, step 2 is going to be use the variables and the other information in the question to write an equation. After you've got your equation, the third step is to rearrange and solve and make sure you go back and answer the question. So let's go and have a look at how we can use these steps and apply to an example. So we have cans of soft drink are sold in Super Save in packs of 12, costing $5.40. We need to form and solve a linear equation to determine the price of one can of soft drink based on the 12 cans costing $5.40. So the first step is to define the variable in the question. Our variable in the question is a can of soft drink. So we'll let cans equal C. Step 2 is to write an equation. So going back to the information in the question, I can see that 12 cans cost $5.40. So I can use that to write an equation, and my equation is going to be, instead of using 12 cans, it's going to be 12C because I've already defined my variable cans equals C. So 12C equals $5.40. My last step is to rearrange and solve. So looking at it, 12C, I want to get C by itself. So I need to remove the multiply by 12. Opposite of multiplying by 12 is divide by 12. So divide by 12 on both sides. So C is going to equal $5.40 divided by 12, which is 45 cents. So one can of soft drink in my example is going to cost 45 cents. So let's have a look at a second example. The amount of water that is filling a tank is found by the rule W equals 100 T plus 20, where W is the amount of water in the tank in liters and T is the time in hours. So we first need to construct a table of values that show the amount of water in the tank every hour for the first 8 hours. So to complete my table, I need to substitute in my T values into the formula from the question. When T is equal to 1, W is going to equal to 100 times 1 plus 20, which equals 120. When T is equal to 2, W is going to equal 100 times 2 plus 20, which is 220. When T is equal to 3, W is going to equal to 100 times 3 plus 20, which is 320. So now we can see our pattern starting to form, and every time T goes up by 1, W is going to go up by 100, which aligns to the equation because 100 is my gradient. So I can now go ahead and complete the table by adding on 100 to every W value. So when T is 4, W is going to be 420, then it's going to be 520, 620, 720, and 820. And I can do a quick check. So when T is equal to 8, W is equal to 100 times 8 plus 20, which is 820. So I've been able to go ahead and complete my table. Having a look at part B of the question, using the table, how long in hours does it take for there to be over 700 litres of water in the tank? So we're looking for 700 of litres of water. So starting at T equals 1, I got 120, and I got 220, so I need to go up to, I reach around 700, and that is going to be 720. So when water is about 700 litres, it will take about 7 hours based on the table to fill up 700 litres of water. It's not required in the question, but I can check my solution by going through and applying my 3 steps. So the first step, define the variable in the question. it's not required because it's already done for us. T is time in hours, W is the amount of liters in the tank. Write an equation. So again, from the question, it is W equals 100T plus 20. But this time, I'm not going to substitute in a T value. I'm going to substitute in a W value. So when the amount of liters in the water is 700, what is my T value going to be? So it's 700 equals 100T plus 20. And now I can apply step 3 to rearrange and solve. So to get T by itself, and applying my reverse bitmass order, I need to remove the plus 20. Opposite of plus 20 is to subtract 20. So subtract 20 on both sides. So 680 equals 100T. Now to remove the 100, I need to divide both sides by 100. So T equals 6.8. So 6.8 hours is close to my estimate of 7 hours I found using the table. So that is some examples of how we can use linear equations and solve word problems.